We want to quickly look at rank correlation. Rank correlation, and this is a continuation of correlation and regression. Good. We'll be looking at Spearman's correlation coefficient. Spearman's correlation coefficient. And what does that mean? It's an alternative method for determining the amount of correlation between X and Y by using the ranks of the scores instead of the actual score. The last one we did, the product moment correlation coefficient, we made use of the actual scores. But this is another method. In this method, we are going to be using the ranks of the score. Ranks means that we'll be arranging them in descending order or ascending order from the highest to the lowest, and we are going to give them positions: first position, second, third, fourth, and so on. That's what we mean by ranks. Okay, now let's quickly look at an example to substantiate the point we want to make today. Given the scores of 10 undergraduates in mathematics and physical chemistry tests as shown in the table below, and this is the score given on the table. We have the mathematics scores, and we call that variable X, and our physical chemistry score, we call that variable Y. Okay, now let's look at what we have in our next slide and see how the solution goes. The solution to that example. So the first thing we are going to do is all the variables we have over there, we are going to arrange them in descending order. You can see mathematics score, we arrange it from the highest to the lowest, and we give them rankings. So 90 is the first position, the first, followed by 86 2, 76 3, 61 4, 53 5, and so on and so forth. That's what we mean by ranking. We rank them from the highest to the lowest, that is in descending order. Now let's also rank the other scores, physical chemistry scores, and you see the highest we have for that on that table is 83, and the lowest is 36. So the ranking, we call that R subscript Y. The ranking for the mathematics score, we call that R subscript X. So we rank them orderly, 1 to 10. There are 10 data that we have. So the first thing we do when we are solving the rank correlation, okay, and the Spearman's rank correlation coefficient, is to first do the ranking, ordering them from the highest to the lowest. Good. Now let's continue solving as we look at the next table that we're going to have. So all the variables that we have, the way we had it in that table, they are arranged 53, all the X variables. That X variable, remember, is a mathematics score. And our Y variable is the physical chemistry scores. They have been arranged. So the column, the third column, which is the Rx and Ry, those are the positions assigned to each of those data. 53 on mathematics column was assigned 5, position 5. 38 was ranked 8, 61 was ranked 4, and so on and so forth. And if you look at the fourth column for Ry, 48 was ranked 7, 36 was ranked 10 on that table, 67 was ranked 3, 47 was ranked 8, and all other rankings are put against each of the value. Now the next thing we need to do is to quickly look at the column we have. So if you look at the column, okay, if you look at the column, the next column, which is D represents the difference That's the fourth column. 1, 2, 3, 4, 5. The fifth column now. That's where we have the D. That's this column. That's where we have the D. Good. We find the difference between the Rx and Ry. So the difference, 5 minus 7 gives us minus 2. The other one gives us minus 2 as well. 4 minus 3 gives me 1. 2 and 8 gives me 2 minus 8 gives me minus 6, and that is all that we have on that table. Now if you look at 10, this 10 minus 5, I have 5. 3 minus 2, I have 1. 6 minus 9, this 6 minus 9, 6 minus 9, I have minus 3, and so on and so forth. And that's how we're going to get our Rx, or our D column. Good. So that's, let's look at what we have next. Our D squared column. That's the last column to my right, the D squared. So we square each of the values in that D column, so we have the whole of that column. The summation of our D squared is 98. Then we have N, which is 10, because we have 10 datas. We are given 10 datas for X and Y variables. Okay, you remember they talk about 10 undergraduates, so when it involves 10 people, so N is equal to 10. Summation of D squared is equal to 98. Now let's see how we apply that to solve. Now this is the formula that you need to commit to memory to solve to get our correlation coefficient, Spearman's rank correlation coefficient. So that's the formula you are seeing on the screen. And let's see how we already know all the variables that appears, or all the things that appears in that formula. 1 minus our D squared, remember the summation that we have there is 98. Our N is 10. We substitute, and when you simplify that, our final answer becomes 0.4061. Okay, and that is the value approximately. Our Spearman's rank correlation coefficient becomes 0.41, and that is what appears on the screen just now, 0.41. So we have come to the end of this particular example, and that has set a strong foundation for us to understand or to solve other ones. Oh, thank you for listening. Thank you.